Hi everyone, we're on lesson 15 and we're looking at reflections in exercise 7B in your textbook, and we're going to be looking at reflections over the x-axis, over the y-axis, and probably over the y equals x axis. Okay, so to start off, we are going to look at reflections over the x-axis. So when we are doing a reflection over the x-axis, and we're doing the actual physical reflection, so I'm taking a graph and I'm going to reflect it over the x-axis, what is basically being done is we have a change in the y's, in the y values. So that simply means that when I have xy, my coordinates xy, they will become x negative y. So all my values of the y will go to negative, and if they are positive initially, and any negative values of y initially will then go to positive y if they reflect over the x-axis. Now, again, just as we had seen with the translations, when we are looking at the reflections, because it's the y values that are changing, then we're looking at negative f of x, meaning that the y values are being affected. So if the y values are being affected, then there's a negative in front of f of x, because recall that f of x is referring to the y value. So any y value will go to negative y. Okay. Now, if we want to do a reflection, though, not only actual physically do the reflection, but we want to know algebraically how to find out what the new equation of that function is going to be once it goes through a reflection over the x-axis, then what we do is we simply isolate for y. Okay, so if we look at the example that is here for us, okay, the example that says here, find the image equation of y equals 2x squared plus 5x minus 5 when it's reflected in the x-axis. Because I am looking at changing f of x to negative f of x, that means that the y is being isolated for, and therefore I'm going to put a negative in front of the entire equation, and everything inside the parentheses was going to change to its opposite sign. So we took y equals 2x squared plus 5x minus 5, and we've placed a negative in the front because only the y values are changing. And so this will go to negative 2x squared minus 5x minus 5. So if I need to find the image equation of the next two examples here, which we can do very quickly, the image equations, one of the image equations would be, so for y equaling 3x plus 2, y is isolated for, and therefore I'm going to say y is equal to the negative of 3x minus 2, which is nothing more than negative 3x plus 2. So that is my new equation once it's gone through a reflection over the x-axis. And if I have y equals negative 2x cubed as my next example that's being reflected in the x-axis, then technically I'm saying y is equal to the negative of negative 2x cubed, which will take me to a positive. Okay, if I want to do a reflection over the y-axis, well, the reflection over the y-axis entails that it's only the x values that are going to be affected by the reflection over the y-axis. So what that means is that wherever I have an x, so notice that f of negative x here, f of negative x refers to a reflection over the y-axis, because what's being affected are the y values. That are being affected, I apologize, are the x values. So if I want to have only the x values involved, then wherever I have an x, I will just replace it with negative x. So essentially, when we reflect a graph over the y-axis, it's the x values that are going to change, and then xy would go to negative xy. And you could see that from the graph here on the left, and above rather. The red graph on the left is our f negative x. So our x values are changing. They're going from positive to negative, and that simply means that if they're going from positive to negative, the y values stay the way they are. Go. So when we are working out algebraically the image equation over the y-axis, basically the general rule is wherever there is an x, I will replace it with negative x. So given the following question, so if you are given the following question where it's f of x equals x squared minus 2x plus 3, if I'm finding the image equation of over the x-axis of that, then I will, wherever there's an x, I will replace it with negative x. So that it'll become f of x is equal to negative x all squared minus 2 times negative x plus 3, and that goes to x squared plus x, or plus 2x plus 3. And there is my solution to that. If I have to find the image equation of the following next example, y equals 5 over x, then if I'm reflecting it again over the x-axis, over the y-axis, wherever there is an x, I will replace it with negative x. So y equals 5 over negative x, which simply becomes negative 5 over x, the negative of 5 over x. And again, the same thing in the third example of 2x minus 3y equals 4 over the y-axis. So that I'll say 2 times negative x minus 3y is going to equal 4. So negative 2x minus 3y equals 4. And there's my final solution. Now, the very last example that I want to give is the reflection over the y equals x line. And what the reflection over the y equals x line is, so here's my y equal x line. It is the dotted line. And the dotted line is going to be the y equals x line because for every value of x, I have the same value of y. So in drawing my dotted line for the y equals x, I have 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so forth, and also in the negatives, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, and so forth. When I reflect something over the y equals x line, what I am doing is I am swapping my values of the x and y, of the coordinates, the xy coordinates, so that they become yx. So in other words, if you take a look at the graph here that is on the side, my original black graph, the y equals x squared graph, has the points 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, and negative 3, 9. In completing the reflection over the y equals x line, that means that what I'll be doing is I will be swapping the x and y values. So my x will become my y value, and my y will become the x value. So that, just to give a clear understanding, the point 0, 0, when I swap x and y, is just going to still be 0, 0. When I swap 1 and 1, it's still going to be 1 and 1. But when I take the point 2, 4, the point 2, 4, when it gets swapped, when the two coordinates get swapped, become 4, 2. And therefore, 3, 9 will go to 9, 3, and the other 2 points, negative 1, 1, will go to 1 and negative 1, and negative 2, 4 will go to 4 and negative 2, and 9 and negative 3. Okay, so algebraically, okay, this is section 14F in your textbook, so you must be very well aware of this because we are going to be working in section 14F, and we're starting right now. Algebraically, when we have to find the inverse equation, so I don't want to figure it out, I don't want to see where it's going to be on the graph, but I want to know algebraically what's my new equation going to be, then what I do is when we find the inverse equation, well, we do exactly the same thing as we did graphically, in that I will take my y's and my x's and I will swap their positions. So given, here's my first example, f of x equals 2x plus 7, and I'm going to find the image equation over the y equals x line. So I will write f of x equals 2x plus 7, and then I will write y equals 2x plus 7, because remember that f of x and y are exactly the same thing. And then from there, I will switch the positions of the x and y. Wherever there was an x, I will place a y. Wherever there was a y, I will replace with x. And when I've done that, I will then isolate for y again. So here you see x is equal to 2y plus 7. Well, now I need to isolate for y again, because our equations are written as y equals, or f of x equals, or k of x equals h of x, and so forth. And when I have isolated for y, I get y equals x minus 7 over 2. And my symbol for showing an inverse function is by writing it as f to the power of negative 1 x. So when I see f inverse, it's f to the power of negative 1 of x. And therefore, there is my inverse, or my new function. Let's try one more. We'll do one more question of this nature, and then I'll send you off for your work in class. Okay, so I have f of x equals 4 minus 3x over 5. So I'm going to swap the f of x and turn it into y equals. So y equals 4 minus 3x over 5. Now I swap my x's and y's. So swap x and y so that I get x is equal to 4 minus 3y over 5. And now I isolate for y again. So we isolate for y because we want our answers always to be in terms of x, or in other words, isolating for y. So that I will cross multiply here, and I'll say 5x is equal to 4 minus 3y. And I will then, I've decided I'm going to bring my 3y over to the left-hand side because I don't want to have a negative 3y. So I'll do 3y is equal to 4 minus 5x, and therefore y will be equal to 4 minus 5x all over 3. And therefore now I can rewrite y as f inverse x equaling 4 minus 5x over 3. Okay, let's try. I think that's where we're going to stop then. So you'll get your classwork to work on next week. Have a good weekend, and I'll see you on Monday.